find the scalar equation of the plane that passes through point -1, 2, 1, and it's perpendicular to the line of intersection of the plane x plus y minus z minus 2 equals 0, and 2x minus y plus 3z minus 1 equals 0. So take a look at this. Here is the picture of those two planes. Now let's read this again. It says, find the scalar equation of a plane that passes through point -1, 2, 1. So -1 is going to come out the back here. 2 is going to run to the right 2 and then up 1. So we're probably going to be somewhere in there, something like that. So that's our point P, and it's perpendicular. And the thing is, we're creating a scalar equation of the plane that passes through that point and is perpendicular to the intersection of planes, blah, blah. So these are the planes here. So we're going to look for so we have this line here as well. I should move my P a little bit just to kind of get an idea. And it really doesn't matter if it's a little off. So I'll put this in first. Point P could be a little higher than that, so we'll just put it there. Okay, so anyways. So now looking at this, we're trying to find a plane, right? Find the scalar equation of the plane. Okay, but it contains this point P here, and it's perpendicular to that line. Now, one thing we can say, if it's perpendicular to the line, then it would be perpendicular also to both of those planes. Hopefully that's okay with you. If not, get a hold of me. All right, so again, if I'm just looking at an instance like that, like this plane is going to be perpendicular to those two planes, then, so now how do we find a plane that's perpendicular to two planes already? Well, we do that by the normal vector of each of those planes. So now I can have this normal vector here, and I can also have this normal vector down here. Now I should kind of redraw these so they look a little nicer. So I'll call this one here N1, and I'll call the one coming off of this purple one on the bottom here N2. Oh, and I'll call this one N1, excuse me. And I'll call this one N2. So if we know the normal vectors of those, then we could find a vector that's perpendicular to those, and that would actually be the normal vector of the plane we're trying to find, which is this one here. Okay, so that's all we need to do here. So when I look at this problem here, and I look at these planes here, do I see the normal vector? And hopefully we see them right away, because it's just the numbers, the coefficients in front of my x, y, and z when I have it in this form here, which is standard form. I can just look at those. Now when I have all my x, y's, and z's on the same side, that's my actual normal vector. So my N1 then would be 1, 1, -1. And my N2, whoops, would be 2, -1, 3. And then if I'm going to find that normal vector of them, which is going to come out this way, and that's going to be the direction of my new plane that's perpendicular to these two, I would have to take the cross product of those, because a cross product of two vectors gives me a vector that's orthogonal to those two vectors. So it would create a vector here, and it would be like this. Okay, so that's what we're going to do now. So I'm going to take that N1, 1, 1, negative 1. And I just think of the ijk up here. Essentially what I'm doing is I'm setting this up for my cross product. So 2, negative 1, 3. And remember, I kind of just cover them up. So for my first one, if this is an issue for you too, go back to the video where we talked about calculating cross product. Okay, so I'm going to cover up this first column here. I'm going to call it I though, and that's going to be my I component, the first one there. So I'm not going to put the I in there. And that's just 3 times 1, which is 3, minus negative 1 times negative 1, which is 1. So 3 minus 1 is 2. And then for the middle one now, get rid of this. And then when I cover up the middle one here, that's going to be my j. And first I have to put a negative there. That's the rule. It's positive, negative, positive. So this one I have to put a negative automatically. Cover that up. And 3 times 1 is 3. Minus negative 1 times 2, which is plus 2 because it's negative 2. So it's 3 plus 2, which is 5. And it would have been positive 5. So I had the negative on that, so I got to make it negative 5. Now for the third piece, so I cover the third one up, and I get negative 1 times 1 is negative 1, minus 2, so that's going to be negative 3. So there's our vector that's orthogonal to those two vectors, n1 and n2, that are the direction of the planes that we started with. So now that we have the normal vector, now this vector here is going to be the direction of our plane that's orthogonal to the other two planes because their normal vectors are orthogonal. So remember what we need to come up with an equation of a plane. So first, now we have the normal vector. And when we look at the definition here, we also need a point. Remember, a point and a vector, the normal vector. So we have the normal vector now, so let's find the point. Oh, here it is. Now we're pretty much done with this. So again, remember that n is the coefficient of what time multiplying by x minus my x naught, or timesing by my x minus my x naught. So that's going to be 2, there's my a, and then 2 minus negative 1, so plus 1, plus, or I'm going to write a minus here because my b is negative 5, and then my y minus y naught is 2, because there's my y naught, and then I have minus, and because that's a negative as well, 3 times z minus 1, and that equals 0. So that's my general form of the equation of a plane. So from here, I can simplify this a little bit, and I think that's okay too. It doesn't matter, but you can. And that's going to be 2x plus 2 minus 5y plus 10 minus 3z plus 3 equals 0. And then from here, I can just simplify it a little more. Oops. And with these numbers, I'm going to get 15. So there it is. Or I can move the 15 over to the other side if you choose. Minus 3z equals negative 15. So either one of those answers are good. Should you simplify? Yeah, probably. At least down to this. This if you feel happy. Okay, there it is.